Hey everyone, so hope you had fun in the last two tutorials. You had a basic understanding of isobars, lines of constant pressure, and now hopefully fronts and finding pressure centers. Now we're going to move on into the 500 millibar charts, and I'm not going to spend too much time on other charts because I think they're irrelevant for what I'm trying to achieve here. But what you need to know is that there are different levels in the atmosphere. So far, we've only been doing surface maps, so near the surface, which is usually around 1,000 millibars. Now we are going to shift gears to 500 millibar heights. So it goes 1,000 millibars, 925 millibars, 850 millibars, and then, sorry, there's 700 millibars, 850 millibars, 500 millibars, 250 millibars. Technically, you could look at every chart, every height of the atmosphere and do an analysis, but we're not going to do that. I'm just going to show you 500 millibars, and this is going to be important when we start next week with our forecasting and our severe weather focus on combining everything that we've just learned into our map analysis. So for now, I want you to go to the Storm Prediction Center. Just Google that, and then you'll find this page. And you're going to scroll down. You're going to go to this square where it says Forecast Tools. You're going to click on the very far right circle. And it's going to shell out upper air maps. You're going to click on that. It's going to take you to their surface and upper air maps archives. So here you can go back. These are all the heights that I was just talking about. You can print them, and you can go back, find days that you would like to analyze, and you can select your levels here, surface, you can download all of them, etc. So what I want you to do, if you're grabbing these maps, make sure that you select the horizontal and not the vertical image alignment. But the only thing I want you to grab is I want you to grab the 500 millibar objectively and analyzed map. You're going to click on that, or you're going to go back to the day of this tutorial. I'm going to tell you which map I'm using, and I'm going to send it to you. But I want you to grab the already analyzed map, and we're going to go through it together. I'm going to explain to you what you're looking at. We could do an analysis on the 500 millibars ourselves, but I think it's irrelevant for what we're trying to achieve. All we're trying to do is we're trying to see what's going on in the 500 millibar in the atmosphere, and 500 millibars is a key level in the atmosphere. This is the first thing you should be looking at when you're looking at model data. That's why this is very important. Now, go ahead. Right after this, I'm going to tell you which day I'm using. So put that in your archive, pull that. It's going to be the 12Z, so the morning map, and select the 500 level, horizontal, and then get the image. It's going to be a GIF image or a JPEG, a very low quality one, but that's okay. Okay, so now you've got the poor resolution image of 500 millibars, and you're probably doing this, watching this on a separate day here. So for me, I grab the April 13th 2020 map, 500 millibars at 12Z. So the previous website, you can put in that date, and then you'll get this map. Okay, so I wanted to do the 500 millibars fairly quickly. I didn't want to go through the process of making them because I don't really think that a lot of people actually make them. They just print it as is like this. So here you can see, I'm going to pull out my marker here. I want you to notice these lines here. Okay. And previously we had looked at, I'm going to write this down, it's actually important. These are different lines don't know if I can, oh, I can't do that. Okay. Sorry, it's a really poor resolution map. Previously we had looked at lines of constant pressure. These are the same here. However, before we called them isobars. Remember, we are doing an isobaric analysis. So now we are doing something different. These are called geopotential height contours. So can't really see anything with this this map here. But yeah, just keep, maybe write this down in your notebook. These lines of constant pressure are called geopotential height contours, and these are exclusive to the upper height charts. Something to keep in mind. These are not called, we're not going to do an isobaric analysis now. Okay, so this map depicts the same thing as the surface maps. The direction of the wind, the temperature is going to be very cold. 500 millibars is a few kilometers in the atmosphere. We're going to talk about this in more details next week and the next few weeks. When it comes down to forecasting, we need to know exactly which heights we're looking at in the atmosphere. But for now, we're just going to go through this generally quickly. And you have the same thing. So you have moisture and you have temperature. It's the same thing exactly as the surface map, except it's higher up in the atmosphere. And you have your pressure here. Okay. So if you really wanted to, you could grab the blank map and draw these lines yourself. But we're not going to do that in interest of time, and I think it's useless. So there's one thing you need to notice here, and last week we did low pressures and high pressures and fronts. So we could do a similar analysis at every height in the atmosphere. Here, 500 millibars is one of the critical ones because we're going to start talking about troughs and ridges, and we're going to talk about upper lows and upper highs. Now, we need to look at this pattern in a little bit more details. And in the next section, I'm gonna talk to you about general patterns and what they look like. But for now, the first thing you should notice on this map here is this area here. Now, does that look familiar at all? It should, right? It should look familiar because you have counterclockwise rotation here. It's a big circle. Like this. That's the first thing you should have noticed on this map straight off the bat. For now, the only thing I want you to do on this map is I want you to realize this, that it's a counterclockwise rotation, therefore there's going to be a big low pressure here. Now I'm going to blow it out even bigger. 105. Okay. Right here. Right? This low pressure is called an upper level low pressure. Upper level low. So if you ever hear that, now you know what it means. You just found one. This means that it's a low pressure in the upper levels. So now, before we go into too much detail about this map, I need to explain to you what a trough is, a ridge is, and general patterns. So we need to do a little bit of a theory here to understand what we're about to do. Okay, so let's just go through a general pattern together. And okay, so there's a few patterns that you're gonna, the more you look at the 500 millibars, this is for 500 millibars, sorry. It's 500 millibar charts. Okay, you need to look at a few examples of, pull a few 500 millibar maps, and then you'll start recognizing these patterns are very common. But for now, I'm just going to draw them. And let's just do this. These are going to be your geopotential height contours. No, sorry, I'm going to remove this arrow. Let's just do a simple one here. Okay. So, say you have something like this. The first thing you need to realize when you're looking at geopotential height contours, I'm going to actually write the gonna put these in black so it's consistent. Okay. So, say you're looking from the west, and this side here is at the east. Okay. In North America, weather patterns will move from west to east, always. So, these geopotential height contours here, what do they mean? Well, we know that these height represent equal pressure, right? So what does this mean? It means that the winds will be blowing from the west to the east in this case. So you need to visualize this, that the wind is doing something like this in between these geopotential height contours. So whenever you see geopotential height contours, like we just saw on this map, you need to visualize the wind doing like this. Cool. So you see this pattern. This pattern is called meridional. Let's just keep it simple. Zonal. This pattern is called zonal. Now, what does zonal mean? Zonal means this pattern. Let's just keep it simple. This zonal means this pattern. Zonal will mean fair weather, generally no upper level lows. Cool. Now, you need to know this, and we're going to look back at the map and see whether it's zonal or not. So let's move on to the next pattern you might see. Erase all of this stuff. Okay. Let's do this again. So, let's say your geopotential height contours are doing something like this now. Don't want that. Okay. What does this mean? Okay, so let's draw our winds again. Our winds are doing this, right? In between. Oops, it's too curved. Right? Okay. So what is this pattern? What is this pattern? This pattern is meridional. Hard word for me to say. Okay, so what does this mean though? Meridional means active weather. This will be your severe weather. This will be your winter storms and severe weather outbreaks. Okay. Cool. Now I want to spend some time on the meridional ones because those are the more interesting ones. Now we did the winds at 500 millibars. In blue are going to be the 500 millibar winds. Now, what are the winds doing at the surface? Because we just spent, last 2 weeks talking about surface. Now, does this pattern look familiar at all to you? Well, the map we did last week, finding our low pressures, had a pattern something like this in our isobars at the surface. So we're going to talk about southerly winds and northerly winds again, and this is where it comes in handy. Now I'm going to draw the winds at the surface. On the eastern side of this meridional flow, you will get southerly winds at the surface. Going to the north. And when I say southerly winds, it means coming from the south. I'm going to write it down. It's going to be in red. And that's going to be at the surface. Okay, now on the western side of this meridional flow, you're going to have, going to have northerly winds. Now, this concept is actually very complex and hard to explain it without going into like very complex equations. So I'm gonna just leave it at that for now. It's just memorize this. And these are northerly winds. Coming from the north. Not this north. Okay, now one of the things that you should have realized is this area here. Now you see that and again, sorry, these are at the surface. So what's happening here? What does it look like? Well, you can notice that if we have northerly winds on the western side and we have southerly winds on the eastern side, you would have a counterclockwise circulation at the surface, right? I hope in your head you just had a big oh moment. So just by looking at this pattern here, you should be able to discern that there is going to be a big upper level low pressure. And it's going to be right here. All right? Okay, now this is like the very basic thought process. Now, again, the counterclockwise at the surface is the very important part here. And I want you to keep this in mind. This part of the tutorial should go into geostrophic and ageostrophic winds, but we're not going to talk about that because it's way beyond what we're trying to achieve here. But screenshot this, you'll use it as a reference, and then screenshot the zonal one we did just before, and you're going to be using these as reference. Now we're going to go back to our 500 millibar maps that we grabbed from the Storm Prediction Center. We're going to find southerly winds, northerly winds, and the low pressure. Okay, so now we are back to our wonderful low quality image, 500 millibars. Okay, so we already found the low pressure, and the pattern is very similar to what we just looked at as a reference, right? So let's find our surface southerly winds on this map. So we said it would be on the eastern side of the low. Okay, like this. And now let's find our northerly winds. Generally something like this. Now, you get this, right? I mean, just looking at it visually, you should be able to understand that these wind barbs are coming from the north, and the wind barbs here are coming from the south. It's not entirely true, but let's just keep it simple. So now we want to delineate what this pattern is. And this pattern is called a trough. Okay. And a trough is a line separating our northerly winds and our southerly winds without going into too much details. Basically, all I want you to do here is what you do is you draw a line like that. Usually it's a black line and it's a dotted line. Let's just keep it really simple and do it like this. So this is called a trough. And the way you write it, T-R-O-F. Cat's going crazy. That's too big. And then this text is going to be in black, and you're going to write it like that. Now, I want you to realize something here. I want you to realize, you remember when we talked about the surface map where the isobars had kinks in it and weird gaps? So I want you to find these gaps in this map. Well, I will for you. You see one here. You see another one here. You see another one, you know, here, here, here. Just little kinks in the map, and the geopotential high contours. So this is where you would put this dotted line. Like this. Okay? And you would erase The southerly is just for understanding the map. It's not, doesn't really belong here. Now, for the 500 millibars, this is all you need to do. You need to know where the trough is. And you just found it. Now, in reality, it's a little bit more complex than this, but for our purposes, that's all you need to know about this map. And what's important about this map is you know that this is an active severe weather pattern. Okay? Active. Meridional flow. Now, this is the only thing you need to know about the 500 millibars, in my opinion. Now, the next thing we're going to talk about is the ridge. What's the ridge? What's the trough? We're going to just go into that a little bit more detail because that's important for severe weather forecasting. Okay, let's go back to this example here. This example, I was going to talk about ridges and troughs, so now we're going to talk about ridges and troughs. I'm going to erase this 500 millibar flow here. Okay, so we kind of like alluded at what a trough was. So in this map, you would follow the kinks in the map. I'm going to do my trough in brown, and my trough would be right in the middle here. Like that, and it'd be like this. Then you would write trough. It's way too big. So it needs to be, the text needs to be visible, but cat's having fun. Okay, so we're going to put that right here. So this is our trough. So our trough means that on the western side of it, it basically means that there is northerly winds at the surface and westerly coming from the west. You have westerly 500 millibar. The cat is just going crazy. You have 500 millibar westerly winds. Okay, I'm going to write it down. So if you ever heard Reed Timmer screaming, huge westerlies, so this is what he was referring to here. I'm sure you have in many of his videos. And all of these will be in blue, just so you so you kind of understand visually. 500 millibars coming from the west. Okay, here's our trough. We drew our trough. Now let's find a ridge. Okay, I'm going to erase all of these, but basically keep in mind this surface. Okay, so you see these, you see our surface southerly winds here in red. This is how you find the ridge. Okay, so it's going to be I'm going to erase them because it's going to get very confusing. It's going to be the similar. You find, you know, here like we found the kink in the isobars going towards the south. You just do the inverse for the ridge. So you see this here, like the little kinks in the geopotential height contours going to the north. This is going to be your ridge. So in this case, you have two ridges, and I'm gonna erase this because that's gonna get confusing as well. In this case, I'm gonna do it in black. You would draw your ridge. That's way too much. Okay, let's just do like this. It's gonna be filled line, and you're gonna write RDJ for ridge. like this. And you probably notice there is a ridge on both sides. That's a ridge and a trough. So why do we go through this process? It's so much work. Okay, it's not, first of all, it's not that much work, but once you get used to it. But here are the kind of like the key points here. A ridge will mean, do this a little bit smaller. Ridge will be southerly winds bringing moisture, warm temperatures, and a trough will be northerly winds bringing cold air, or you call it cold air, cold front. Okay, and the ridge will bring warm fronts. Aha, okay, so that's why it's important, right? It's important because that's how you get fronts. This is like a very more complex way of explaining fronts. So now let's go back to our previous map. This map here. Where is our ridge? You can probably quickly see that our ridge is up here somewhere. And then you would write RDJ. Okay, now the important part about all of this is that you don't need to do this, okay? I want you to do this in your head. I want you to realize this 500 millibar pattern is active. It's going to be an active weather pattern. That's all you need to know in the 500 millibar, so that when you're looking at forecast models, the first thing you should look at is the 500 millibar chart. You're going to look for this pattern, okay? And this pattern just brought a huge tornado outbreak yesterday to Dixie Alley, and is bringing a wind event, damaging wind event to southern Ontario. This is a very active pattern, and on the backside you have a lot of snow because you have northerlies, right? Now that's all you need to know for the 500 millibars. It's probably very complex, so I expect you to go through this lecture multiple times. But the only thing you need to know, again, you need to be able to look at this and recognize that this is an active weather pattern. That's all you need to know for this. I don't expect you to draw the ridges and the troughs, but I figured I would explain it so you can visually see them. Okay, now that you're nice and confused, we are going to go back to the surface maps. Okay, so I don't know if you recognize this map. This is from the first tutorial. We pulled Texas and we did an isobaric analysis on this. Now we're going to switch gear to a moisture analysis. Now, this is, I don't even think that it is in Environment Canada standards to do this. This is kind of what storm chasers do, and I'm going to show you how to do this because I think it's very important. So far we've talked about fronts and we talked about isobars and all that fun stuff. I'm going to zoom in here at our surface observations. So far, we've been looking at mostly the temperature and the pressure, right? And the direction of the winds. Now, for this analysis, we're only going to look at the dew point. Okay? This is the only thing we want to look at here. How I do my analysis is we're going to do the same thing that we did with the isobars, but we're going to, in the isobars, we're trying to connect isobars that are, and then try to figure out which ones were the same pressure, and we were grouping them into lines of constant pressure. Now, what I want to do here with a moisture analysis, I want to group dew points. And what this will do is it will show me visually where the biggest moisture is. And moisture, very important for severe storms or for winter storms, precipitation, all that stuff. And we're going to talk more about that and how we can apply this into making a forecast next week, in the next few weeks. But for now, I need to show you how to do this. And it's fairly easy. I'm going to show you on the computer, and then I'm going to print this map, and I'm going to do it by hand like you should be doing it. And you're going to need a green marker, and you're going to need a green coloring pencil. For now, just do all of this in pencil because you're going to make a lot of mistakes, and I'm probably going to make mistakes in this map. Right, I'm going to write down, this is what I'm going to look for first. Dew points. I usually start at 65. I'm going to put this in. So let's look for dew points 65 Fahrenheit. And I'm going to start circling some of them here. Okay, 55 here, no good. 56, 57, no good. If you find a 65, let me know. I actually do not see any 65 here. So we're going to blow it back and we're going to go 60. Are there any 60 Fahrenheit dew point? Okay, I see one here. And I see one here. So this map actually doesn't have too much going on here. I see a 65 down here. So for explanation purposes, I'm just going to do the 60. Here's what I'm going to do. I'm going to grab my pencil. I'm going to connect the 60. Let's go through that one, this one, and then bring it down here. So it's similar to the, sorry, I'm going to redraw that because it doesn't look like nice. So you see here we have a 63, we have a 61, we have 60, 60, 62, right? So it's a similar thing that we do for isobars. Just draw my line here. Must go through the 60, must go through the 60 here, like this. And now I'm going to write 60. Put that in bold. Put it in black for now, not bold. And similarly to labeling your isobars, you're going to put that on each side of the line. Okay, now we found 60. Don't see any more. So now let's do, I usually do an increment of 5, so let's go down to 55 now. We're going to do the same thing. I see a 65 over here. I'm going to grab that one. Go like this. And these are going to look very, Very funny. But let's do this like that. And that would be at 55. Then connect the other side of this here. Let's see. I got a 55 over here. Okay, let's do this. 55 here. Got a 56 here. These are the ones that are gonna make probably the most mistakes. This is usually the ones that I always have to go back, connect that line. Got 49s here. $55. Okay. Something like that. It looks really funny. Got a 53 over here and a 55 over there. Gonna exclude it. Sure. Okay, a bunch of 55s here. So 55. This is going to be much easier when I do it with pencil here, but okay, it would be, you know, something like this. And you can set your own arbitrary, like you can do 58, 57, it doesn't really matter. I usually do 55, 60, and 65. There's no point in going lower because that's not very good moisture anyways. Okay, so let's label that 55 here. I'm gonna keep going because there's a 57 here. So I think that's the only one. So I'm just gonna be lazy and just do a circle around it. And call it 55. Okay. Now double check, make sure you didn't miss any. I'm gonna exclude this 67 here because I want to. Okay, so sure. Now what I do is I color all of this. Once I'm satisfied that I did it right with my pencil, I would go and draw over these lines in green marker. Oh. Not what I want. I would put all the numbers in green, and I would put all my lines in green as well. And this was with a green marker. Again, it's a lot easier on not on the computer. Cool. So now you did that. Now you take your green coloring pencil and you're basically going to fill in. I usually use different greens. So for the more moisture, I would use maybe, I don't know, like a darker green or something. And then for the 55, I would use, you know, a different shade of green. So let's just say this lime green. That does not look good. Okay, well, we're going to do an example later. But what you need to do is you take your pencil, your coloring pencil, and you fill in this moisture with your coloring pencil. Okay, you fill all of this area that you just, oh, it looks really bad. Once you fill that out, then you basically just did your moisture analysis. Very easy, right? this map was very easy. But I'm going to do a different example, I think, because this map doesn't really fit the narrative I'm trying to get. But basically what you can see is that all of this area is below 55 dew point. Okay, so it means it's really dry. Probably would not get any severe weather in this area. Now, I'm going to do a live version of an analysis, and I'll show you what it should be look like. You should print this out and do it by hand. Okay, hopefully you can see this. Try to zoom in as much as I could. You'll recognize this map from your homework from last week. Now, this is what you're going to need for this map. We're going to do a moisture analysis. You'll need a bunch of coloring green pencils. You're going to need your green marker, and that's it. Now, I do everything in pencil before, so we're going to do that. The moisture analysis should be done once your full isobaric analysis is completed. So I'm going to start with 65 dew points or more, and already on this map here I can spot 70s. You got 73 here, 71, 75. So I'm going to start pretty high here. And I'm going to grab anything. I see 76 here. It's very moist environment. Okay. 75 down here, 76. So I'm going to start an 80 dew point. I don't think I've ever done this before. It's very high. I'm going to grab it here, down here. It's going to be an 80. There's only 2 stations down here. And now I'm going to do my 75. So there's a station down here. 75, I'm going to grab that one. There's another one here. And there's a bunch of 75s down here, so I'm going to grab all of these ones. Go through all of them. It's going to look strange. Okay, 75 here. 75. It's a pocket of 75, so we're going to close it off. It's going to look very strange. 75. Okay, you probably can't see this very well, but I'm going to go over it on with a marker right now. So here we got an 80, and it looks like this. Now my 80, because we're so high here, I'm just gonna do hashed in green, like that. And then my 75, I'm gonna grab it. It was just a pocket around like this. Was like that. And I'm going to erase my pencil without ripping my page. Again, I'm going to take my darkest coloring green pencil, and I'm going to shade this in here. So this would be dew points between 75 Fahrenheit and 80. Just like so. Okay, now I'm going to look for any other areas that have any pockets like that. Got 66 over here in Florida, 70 here. There's a 75 down here. And 80 pocket of, okay. Yeah, there's another pocket here, so I'm going to grab these ones in Florida. I'm just going to do this one right straight up in marker. It's going to be 80. It's not very useful. We don't really care about what's happening in Florida, but for this day anyways. So let's just keep going here. So my 75 would then go around it. I think there's only one station down here, 75. So I'm just gonna finish down here so it look a little bit better. Okay. And this is going to be shaded in. Again, you can go all out with these things, but just keep it simple for display purposes. It's fairly simple what we're doing, right? Okay, so now I'm going to do 70s. So I'm going to do 70 dew points, and the 70. Let's see if there's any. Okay, there's one here, Florida. So I'm just going to go grab these ones. That. There's a 65 out in the ocean, so I'm going to exclude that all the way down 70. Then keep going near the warm front. Bunch of 70s here. Okay, and it extends, my 70 line will extend all the way down here. So let's double check everything. Okay, here there's a bunch of 70s. I need to go through them. We're looking 75 here, 65 I'll admit. Okay, so I'm just going to draw this in, so that'll be my 70. Oh, you couldn't see that, but okay, here all along the warm front. That's my 70. I'm going to erase my pencil mark. Okay, now you're going to pick different shade of green, and you're going to shade all of this area. So there's one thing you can notice right off is that we have a very large warm sector here. It's a lot of moisture to work with. And it makes sense because this is the Gulf of Mexico. I'm not gonna, you can be very perfectionist if you want, but I'm just gonna shade this whole thing. Okay, so you get the general idea, right? There's a lot of moisture. So now, how I usually finish it off is it's kind of subjective how much you want to finish it off, but what I usually do, I'll probably do another 5 here, so I'll do 65. And I'll start at 65 here. 65 is going to be, there's going to be a lot of it. Okay. 65 near the low. 67. And then it goes into the low. Okay, so your 65 line would end here, right next to the low. It goes like this. I probably missed a few here, but okay. So what I would do is I would leave it off as a 65 on each side here, and I would not fill in between the 65 and the 70 so that it looks a little nicer. You don't want to overcrowd the map either, but erase this line here. So what you need to realize is this moisture area here is what we call moist tongue. Okay? Well, usually because it looks like a tongue going up. But this will become very important when we're doing severe weather forecasts in the next few weeks. But I want you to practice this, find your moisture, maybe set your own thresholds, maybe 50, 55, 60, whatever works for you. But you should practice this, and doing this also confirms what we previously learned. We see I'm going to use a different marker here. We see that we should have northerly winds coming on the western side of the low, right? Northerly winds should not have a lot of moisture, so it makes sense that our moisture tongue kind of ends right here. And our warm front delineates the moisture, right? The warm, moist air is to the south of the warm front. This makes perfect sense. And doing this moisture analysis will help you find a warm front in some cases. In this case, the National Weather Service map, computer generated, had the warm front going like this, straight line. In fact, I put my warm front like this, right? And I put it like that because you can see there's a moist tongue going up here, right? So the warm front should be just paralleling it. So you need to practice this, but the moisture analysis is not too bad, but it will very much help you when you're doing morning analysis before you're chasing.